For this part, we're going to be working on taking the limits of natural log functions. Good way for you guys to see this one is probably more of a graphical approach there, because obviously substitution method's not going to necessarily work out very well, because we have to take, if we put in positive 3, right, we're going to get 0. But this is where we can take the left hand and the right hand limit. And take a look. So graphically is probably your best method. We haven't learned L'Hopital's rule yet, so that's where we'll have to kind of take some derivatives to see what's going on. But for this method, if you graph this in your calculator, you're going to end up with a sketch that looks very similar to the one here. We're looking at example 13. We want to find the limit as x approaches 3 from the right. Remember that little plus sign means to the right, or from the right, of natural log of x minus 3. If you can graph this, alright, just hit zoom 6 on your calculator, good standard viewing window is just fine. You can see that as we're approaching from the right, so I kind of drew it on the graph here, we're coming from the right hand side. Okay, if we were coming from the left, there wouldn't be anything that exists, right, because there is no graph on the left. But we come from the right, and the graph is going down towards negative infinity, so that's why this limit is negative infinity. Let's look at example 14 here. Same kind of scenario. If we did substitution, 6 minus 6 is 0, natural log of 0, alright, isn't going to give us anything. So we have to approach 6 from the left hand side. Remember that little 6 with a subscript or superscript of negative means we're coming from the right. So if we graph the function in our calculator, I would just graph it and take a look at it. As we approach positive 6 from the left hand side, this limit is also going to negative infinity. So this is a good one. Just use your calculator as a tool to handle evaluating the limits and such on this one. Okay. Next, same thing that we've been doing before. We're finding the equation of the tangent line. So remember, we did a lot of that when we first started derivatives. You're going to find the slope, and then you're going to use point slope to find the equation of the tangent line. So those are the two steps with this one. Finding the slope. Remember, the slope is when we take the derivative and we evaluate the derivative at that point. So the first step for us, we want to find the equation of the tangent line to the graph y equals a natural log of x to the fourth at the point 1, 0. So we're going to take the derivative first. Alright, the best way to take the derivative on this one is rewrite it first. Bring that power rule down. Alright, so that 4 is going to go in front of the natural log. So now we're going to have 4 times the derivative of natural log of x is 1 over x. So our final derivative is 4 over x, which is our slope. So we've now taken the derivative of the natural log function. Okay, we have the slope. We substitute in x. Okay, so we get 4 divided by 1, which is 4. So the slope for our equation is 4. And then when we go in, we plug into point slope, our x1 is 1 and our y1 is 0. So if you guys remember point slope, it's y minus y1 equals m times x minus x1. Substitute in our values. So we had the given point of 0, 1, and then we have our slope of 4. So our equation of the tangent line is going to end up being 4x minus 4 when we solve the algebra. Alright, example 16, we're going to do implicit differentiation. So remember, when we do implicit differentiation, we're going to do multiple derivatives of multiple variables kind of at the same time. So in this scenario, we have x and y. And so remember, this is where we have to write things in terms of dy's and dx's, and then end up with dy over dx in our final answer. Okay, so the best approach for me to give you on this one, alright, is try to get all the x's on one side, all the y's on the other, and you can keep the constant with the x's. Everything will work out. But we have, in this problem, example 16 here, we have the natural log of xy plus 5x equals 30. So the first thing we need to do is rewrite that natural log of xy. So we're going to rewrite the natural log of xy, okay, using that multiplication rule. It turns it into addition, so we're going to have natural log of x plus natural log of y plus 5x equals 30. Now let's collect all the x's, all the x terms on one side and all the y terms on the other. So we're going to end up with natural log of y equals 30 minus 5x minus natural log of x. When we do that, alright, we can take the derivative each side. So remember, the derivative of y we always have to write a dy with. Okay, so the derivative of natural log of y is 1 over y times dy. The derivative of 30 is 0. The derivative of 5x is 5x dx. Minus natural log of x, the derivative of natural log of x is 1 over x dx. Remember, every time we take the derivative with respect to x, we'll write it dx. Anytime we take the derivative with respect to y, we're going to write it as dy. Or we could have done everything simply and wrote the first one as dy dx, okay, and then not written dx on anything else. So remember, there's a couple different ways we can write and work through those. So the methodology is the same, it's just the approach. I'm showing you a little bit different one than what we did before. Okay, so we have 1 over y dy equals, I've factored the dx term out of both of these, so we have negative 5 minus 1 over x quantity times dx. So what's going to happen is I'm going to divide both sides by dx. Alright, that'll get me dy dx, and I'm going to multiply both sides by y at the same time so that my y goes away on the left hand side. So I'm only left in terms of dy dx. So when I do that, I have dy dx equals y times the quantity of negative 5 minus 1 over x. And then you can do some different algebra manipulation. Alright, we can distribute the y through, and then we can multiply the left part of that term by x over x so it has a common denominator. So when you're doing your homework or things like that, it's one of those where you might need to do a little bit of algebra to get to the right answer and that sort of thing. Okay? The next video, I'll start this on the next video, is finding any relative extrema and inflection points. So if you remember from when we did that before, we're looking for the first derivative, setting it equal to 0, second derivative, setting it equal to 0, finding points of inflection, finding critical values, all those different things. But I'm going to pick that up in the next value because example 17 is going to take us a little while to go through. There's a couple of problems on your homework that it's associated with. So as always, feel free, email me with any questions.